Here's an example that involves the segment addition postulate. We have a couple of segments. We're going to end up adding them together and using that concept here. So let's take a look at this particular problem. The length of EG is 59. So from E all the way to G is 59. So from here all the way over to G, that's 59. The question is, what is the length of EF, this length, and FG, this length? So how do we split these up? It's not half. Doesn't say anything about them being the same measure. Matter of fact, it looks like this one's longer than that one, although that doesn't really matter. So what we do know, though, is that this segment plus this segment has to equal 59. So we're going to write it that way. We're going to use a little algebra here. We're going to say 8x minus 14 plus this one, 4x plus 1 equals 59. And we're going to solve the equation for x. So we're going to combine your like terms. 8x and 4x is 12x. Negative 14 plus 1 is negative 13. That equals 59. We're going to add 13 to both sides. We're going to get 12x equals, that's going to be 59 plus 13. Just to double check it, I will use my calculator. So 59 plus 13 is 72. So that equals 72. And then we're going to divide both sides by 12. And so x would equal 72 divided by 12, which is 6. Now, that is not the answer. That is simply the measure of x. That's what x would be here. So in order to find the measure of these, excuse me, we're going to take 6 and plug it into these equations up here. So if I put 6 in here, I get 8 times 6 minus 14. And I can simply do 8 times 6 equals minus 14, and I get 34. So I can get 34 for segment EF. Now, I could plug 6 in there and get the measure of FG, or I could simply take 59 minus 34, which would also give me the same measure. 59 minus 34 is 25. So I know that that measure is 25, but you know that 4 times 6 is 24, plus 1 would make it 25 anyway. So there's the measure of EG, and there's the measure of FG.